Hello guys, welcome back. In this video, let us learn about one more important topic and one more important service in AWS. And this service is very important for data engineers as well. And whoever the persons they are learning AWS, this is very important for them. Now, in real time, big data is quite natural, right? Yes. We may get big data from multiple sources. Either it may be from financial analysis. If you want to analyze financial information, then it's quite natural that you may have a lot of files there. To analyze that much of data, we need big data analysis, right? Yeah. Also, the data may be coming from scientific simulation. Let's say you are performing any scientific experiments. Then at that time, in order to get better results, you need to analyze a lot of data to get better and accurate results, right? Yeah. Under bioinformatics, in medical industry also, big data analysis is very important to get some accurate results. And in machine learning, so in machine learning, this big data and this big data analysis training a model is very important to get the best ML models to perform some automation tasks or to achieve any important task, right? Yeah. And even if we focus on AWS, then we have logs, right? Yeah. So those logs will be generated from multiple services. Now, in order to analyze those many logs, nothing but big data analysis only, right? Yeah. So analyzing that logs may be one of the source also. And if you focus on data storages like data warehouses, then those also comes under one of the big data, right? Yeah. So analyzing that data warehouses also comes under big data analysis only, big data processing only. And if you focus on browsing, web index is also there, right? Yeah. So that web indexes browsing will be also comes under big data. So in that big data, the indexing will be happen to your content based on the fetch, right? Yeah, if you host any website, then there are multiple websites in the web browser. So among those all websites, based on client's search or user's search, your data will be indexed, right? Yeah. So how that indexing will be happen? After analyzing a lot of big data, that is many websites we call it as big data only. So analyzing those big data, that much big data, we can able to provide indexing, right? Yeah. The sources may be many in real time, but we focused on normal use cases, real time scenarios. Now we got big data from these many multiple sources. So the source may be anything, single or multiple sources. Now what you need to do, you need to analyze this big data, right? Yeah. So in order to analyze that big data, you first need to process that big data, right? Yes. So to process that big data, do I have any frameworks or do I have any tools available in the market? The answer for this is yes. We have multiple tools and multiple frameworks available in the market. Among them, the famous one is Hadoop framework. By using this Hadoop framework, we can able to analyze very large data, that is very big data. We can able to analyze by using this Hadoop frameworks. Whereas if you want to analyze this big data in your on premise, then what you manually do, you first need to create multiple servers, and that means you must need to take multiple laptops, or you can say computers, or we can say them in technically as servers. You can take multiple servers, and in all those servers we need to install this framework, or we need to install whatever the software or dependencies required. Then only we can able to analyze this big data, right? then only we can able to process this big data. Sometimes it might happen so that regarding CPUs and storage issues may happen, that is storage is insufficient and CPU is not sufficient to process that much of big data. It might happens in your on-premise, in our on-premise. Now, in order to overcome this, so in order to overcome this burden, AWS comes up with a service to process our big data by using Hadoop framework. So what is the service, sir? That service name is EMR. What is that? EMR, Elastic Map Reducer. By using this service, by using this Elastic Map Reducer, we can able to process our big data by using frameworks like Hadoop. So what about underlying infrastructure, sir? Do I need to manage the underlying infrastructure? Do I need to create individual servers? And do I need to install software individually in all my servers? The answer for this is no. You don't need to install your software or frameworks inside each and individual servers every time whenever you are launching an instance, whenever you need to launch instance. This launching of instances and installing your software dependencies, everything will be taken care by AWS. So you have removed the burden. This AWS removed the burden on you regarding installation of dependencies, softwares on your systems. And one more thing, here if you use AWS EMR, then you can even able to overcome the two issues that you faced on-premise, that is storage issue as well as CPU, that is processing issue, compute power issue as well as storage issues. Those two will also be overcome if you use this EMR, because in this EMR scalability is there. Don't worry, I'll tell you the underlying infrastructure, how the underlying infrastructure will be and how it will be created in AWS EMR. And one more important point is, by using this EMR, you can even process big data with other frameworks. That is, this EMR even supports you to process your big data by using other frameworks like Apache Presto. You can also process by using, it also supports other frameworks. What? Other frameworks to process your big data. That is Presto, Apache Spark, and Apache HBase. So it also supports these frameworks in order to process your big data on your EMR, on your EMR. So basically, how the infrastructure will be on your EMR. So let us see that. In EMR, your infrastructure will be created in the form of clusters. So here also clusters will be created. In this EMR cluster, mainly we have three types of nodes. We can able to provide three types of nodes in this EMR cluster. The first type of node is master node. What is the first type of node? Master node. Actually, this master node will take the queries or take the data, and then this master nodes distributes your data or query for processing among other nodes. Now let us see other type of nodes as well. And second important nodes are core nodes. What are these core nodes, sir? This is the place where we actually store our data and we actually process our data. This is where actually we store our Hadoop database. This is nothing but it will store, it acts like Hadoop database and it also process the queries or queries of the data which was sent by the master node. And we have another type of node, that is test node. What is that? Test node. Here only processing will be happen. By using this test nodes, only processing will be happen. Sometimes it might happens, there may be a need that you require some more compute, right? Yes. So at that scenario, you can use this test nodes as well. Let's see limitations also. Now, in every cluster, only one master node is allowed. You can able to create only one master node, only one master node only present in the EMR cluster. You cannot able to create multiple master nodes. Where what this master node will do, it can take your data, or this is the person who will take your data at first, or this is the person who will take your queries at first. In order to compute, we send queries, right? Yeah, those queries will be taken by this person at first. Or else if we want to store our data in this EMR cluster under Hadoop file system, then this is the person will take that storage as well. Then after that, it will manage the query, or it will process the query among the nodes, the core nodes as well as test nodes. And if it gets some storage, to store under Hadoop file system, then it will send the data to the core node. So in this core node, actually your storing and processing happen. In this, actually your storing and processing happens. So where it was stored? It was stored in Hadoop, right? That is HDFS. So this is the place where it contains storage as well. So this is the place where it contains storage as well for storing your data. That is Hadoop file systems. And it also process your data. Whenever queries are sent by the master nodes to this core node, then these core nodes will process your data. You can simply assume these nodes as instances, or you can say servers in the backend. Now we can even scale these core nodes based on our requirement. These may be one core node or multiple core nodes based on our requirements. But actually, for storage purpose, these are the core nodes that we use for storage. In the test nodes, we do not able to store our data. So here in this core node, actually your data, that is HDFS storage, under this HDFS storage only your data storage will be stored. Whereas under test nodes, your data won't be stored. These are useful for computing, that is processing purpose only. In this core nodes, you can also use for compute purpose. So you can even create not just a single core node, you also able to create more than, you also have ability to create more than one node, that is greater than one. Core nodes you can able to create more than one core nodes you can able to create. While creating your cluster, you have flexibility to scale these core nodes. How many you want, those many you can able to create. Whereas coming to this test nodes, these test nodes are actually optional. What? These are optional. If you don't create also, then nothing will happen. These test nodes are optional. But these master nodes and core nodes are must, mandatory. You need to create. Because in the core nodes only your data will be stored and processed, and this master node only will sense or will distribute the query or storage among core nodes, right? Even it may be single core node or multiple core nodes. So while creating your cluster, you must need to specify master node configurations, like what is the TPU type you want, what is the instance type you want for this master node and for this core node. And in the core node, you also need to specify the storage, how much storage you want to store. That also you need to specify, so that this master node can distribute the queries or storage among the core nodes based on the instance type you provided, and based on the storage that you provided while configuring your EMR cluster for this core node, that much amount of storage it can able to hold. And based on the instance type that you provided while configuring this core node can able to process the queries which was sent by the master node. And this is optional, those are test nodes. You can even create these test nodes while after creation of your EMR cluster also. So what is the need for me to create these test nodes? Let's say sometimes it might happen you have high traffic of queries, to compute on this storage. So in that scenario, if the available core nodes compute is not sufficient for you, if the available core node compute is not sufficient for you, in that case, you need extra computing instances, right? Yes. So in that case, you can able to use this test nodes. You can able to create these test nodes, and you can able to create more than one test node. You can able to create one test node, or you can even have ability to create more than one test nodes as well. This is how your EMR cluster will be. It has must and should one master node, and it also has one core node with some storage you specified and compute is specified. And this core nodes may be one or more than one. You can able to scale them. And this test nodes, these are optional. If you want, you can able to create. If you don't want, you can not able to create it. And after creating your cluster also, you can able to create these test nodes to increase your compute, and you can even able to delete them as well. So by using the compute, you can able to process the data which is stored in it. So this is how your cluster will be, EMR cluster will be. And these three things are the core components in it, and where your HDFS storage will be stored and compute will be happen on this. How do it overcome the storage issue as well as compute issue? I think you got an idea, because it can overcome the compute issue by providing test nodes, how many you want, those many, after even creating the cluster as well. And you can even scale your HDFS storage in the core nodes after creating your EMR cluster as well. Let's say you have already assigned one job to this EMR cluster. Now you are expecting to analyze that job, or you are expecting to view that job. Then you can even access that job by connecting to this master nodes. By connecting to this master nodes, you can able to analyze that job that you provided to this EMR. So this is theory all about EMR clusters and EMR, AWS EMR. So this is how it can overcome the issue that is coming when you use on-premise servers to process this big data, that is regarding storage and compute and provisioning as well. This is in this way it can able to automatically provide. You just need to configure master nodes, how many master nodes instance type and core nodes instance type, and how many core nodes you want, and HDFS storage, that is the how much storage you want. And here if you want test nodes any, then you need to configure that as well. So you just need to provide a simple click of details in graphical user interface. You can able to do it by AWS management console, so that you can able to create this AWS EMR, that is Amazon EMR, to process your big data. So in this AWS EMR, in this Amazon EMR, Elastic Map Reducer also, we have three types. That is, we have, let's say you don't want to manage the underlying infrastructure. That means you don't want to manage these master nodes, core nodes, or test nodes as well. Then you can have an option of EMR serverless. What is that? EMR serverless. By using that EMR serverless, you even don't need to manage the underlying master nodes, core nodes storage and compute. So those all things also you don't even need to manage if you use this EMR serverless. Let's say you are expecting the control. You are expecting the control of whole cluster infrastructure, that is master nodes, how many you want, core nodes, and their processing CPU or instance type, what you want, and how much storage you want. So in that case, you have an option that is EMR with EC2. You can use that EMR with EC2. You can use that EMR with EC2 option in order to have control on your master nodes, core nodes. So that also available while creating your EMR with EC2. So that option also available for you under this EMR service. So by using that service, you can able to do this as well. And one more option is also available for you if you use EMR. That option is, you can see here, EMR with EKS, EMR on EKS. That means you don't need to focus, or you don't need to have, you don't need to provide instance type, and you don't need to provide the storage as well if you use that EMR on EKS. This EKS is nothing but containerized service. Yeah, here you have more control on your containers. If you want container level control on top of your container, you are expecting to process your data and store your data and process your data, then you can choose this EMR on containers. So by using this option also, you can able to process your data. So these are the three options for you for configuring your EMR with EKS. EKS is a containerized service where you can able to process or store your containers and run your containers on this EKS. On this EKS, you can also implement this EMR functionality as well. So these are the three options which are available to you to use while creating your EMR cluster based on your control you are expecting. If you don't want any control, then you can choose this serverless. If you want a little bit control on this storage as well as compute, then choose this EKS, EMR on EKS. Whereas if you want a full control over instance type, you have specific requirement of instance type and storage and compute, then you can choose this EMR on EC2 so that you can able to create the required number of test nodes, core nodes, as well as master nodes as well in this EMR. One more important point is, in order to manage these core nodes and test nodes, this master node uses these resources, that is yarn resource manager and yarn name nodes. By using this only, you can able to manage your core nodes and test nodes. So even this with EMR cluster for high storage, it also provides you integration with other storage services like Amazon S3 and Hadoop file system and Amazon services like S3 and database services like DynamoDB, Redshift, RDS, and storage services like S3 and S3 Glacier. You can even integrate it with available storage services to get high storage, and we can even integrate it with Hadoop file system to get high storage to overcome the issue with storage as well by using this EMR. Let's say you want to monitor EMR logs, EMR event logs. You have an option that is CloudTrail. Under this CloudTrail, you can able to even monitor the EMR event logs as well, so that you have better control on your EMR service. What happened on your EMR service, that you can able to analyze by using these event logs as well by using AWS CloudTrail service. Let us see pricing option as well. So how the pricing will be if we use this EMR clusters? The pricing will be based on the instance type that you selected for your nodes. So what instance type that you select for your nodes? So I have already told these nodes, you can call it as instances as well. Actually, these instances, if you create on EC2, then we call them as EC2 instances. If we create this cluster with EC2, then we call them as EC2 instances. If we focus on creating with EC2, then the pricing model on that, then whatever the EC2 instance type that you use, based on that your pricing will be, and how much amount of storage that you select for your core nodes. For that also you have the pricing, and the type of instance. What is that? The type of, that is either you want a spot or a reserved instance. So if you select, you have even availability to select spot EC2 instances or on demand spot or on demand EC2 instances. So based on your selection, you may be charged for that type of instance. You can reduce your cost by choosing spot EC2 instances, or else if you want on demand, then you can choose on demand as well. So your pricing will be majorly based on these instance type, storage, and the what type of instance type that you choose. Instance EC2 instance type indicates what is the processing type that you choose, T2 micro, like that. Whereas at last spot instance or on demand instance indicates what EC2 instance that you are using. So I hope you understood the difference. Yeah. So this is where the major pricing will be for storage and for compute on your EMR. So this is all about EMR. I hope you understood EMR service with a good detailed examples, and what are the use cases for this, what are the sources, from where you can able to get the big data, and how can you able to process that big data by using the frameworks, in which service you can able to process your big data. That is, let's say you want to process a Hadoop or Presto, Spark, or HBase related frameworks. You want to process your data by using these frameworks, then we have EMR service in AWS available for us. We can create that EMR in these three ways: by using EC2s or EKS or EMR serverless. Also we can able to create based on our required control. You can able to create, and based on our required management, you need to create your EMR based on these. If you create your EMR cluster, then inside your cluster you have one master node, and you can able to create more than one, or one core node. And regarding these test nodes, these are optional. Actually your data is distributed by using this master node data query, and then it stores data is stored under your HDFS storage on your core node, whereas processing will be happened by using core node as well as test nodes if any have. And how this master node will manage these two nodes is by using yarn resource manager and yarn name node. Even it integrates, EMR cluster will integrate with these AWS services. Like for storage, S3 is there and Glacier is there. For database, you have RDS, DynamoDB, Redshift is there. For other storages like Hadoop file system also there for you to integrate with EMR cluster to overcome the issue with the storage. To overcome the issue with compute, you have an optional test nodes. You can create them. You can create them after your EMR cluster creation as well. And then you have event monitoring as well by using this CloudWatch, that is a CloudTrail logs. And at last your pricing will be based on your instance type, and for storage your pricing will be, that is for storage you have charge, and for instance file type, that is compute instance type, that will be, that you will be charged. So I hope you understood this Amazon EMR theory. I hope this video is contentful. I hope this video is contentful and you got some knowledge from this video, or you have some knowledge recap from this video. If you feel this video is contentful and you have some knowledge recap, or you learned some new knowledge from this, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys.